Alright, so now we are to the negative exponent rule, and I briefly talked to you about it just a moment ago. A lot of times people will use the word reciprocal when dealing with this, and it's technically kind of true, but it leads to a little bit of misunderstanding. The way I like to say it is the reason why we have a negative exponent is because it's kind of out of place. Right now, this x to the negative a is in a fraction in the numerator, and the reason why it's x to the negative a is because this really belongs on the bottom. This should really be 1 over x to the positive a. Conversely, it is also true that if I had been given an example that was 1 over x to the negative a, it would be negative on the bottom in the denominator because it truly belonged up top, and if I moved it to its proper position, it would be x to the positive a over 1. So what it might look like in a problem, and you can test it in the calculator if you just want to make sure, if I have something like 2 to the negative second power, what that really means is 1 over 2 to the positive 2 power, which comes out to be 1/4. So if you put that in your calculator, you're probably going to get the decimal 0.25. So if you know anything about like scientific notation and stuff like that, this has a little bit to do with that. In fact, the negative we know ends up making it a smaller number because it's really fractions and decimals. It's really on the bottom. So if I have a variable like x to the negative 4th power, to fix that, remember it's technically in a numerator right now, I would just move that base with that negative exponent, and it would go to the bottom and become positive. So it becomes x to the positive 4. Well, I'm not just necessarily flipping this thing, but since I'm putting that on the bottom and there's nothing left up top, I have to have a 1 placeholder. Now the reason why I'm not just saying flipping it is because sometimes you'll have examples with several different things. You might have like 3x to the negative 4th y over 9x squared y, and I'm not about to just flip this entire fraction. I'm going to do what I know to do with the 3/9. That's going to reduce to 1/3. Then x to the negative 4 over x squared, if I followed the quotient rule at first, it would be x to the negative 4 minus 2, which is going to leave me with x to the negative 6th, and then the y over y would cancel. Well, the only way that I can fix this is to take this x with the negative 6 exponent and only move it to the opposite of the fraction. So the 1 and 3 are staying where they are, so I still got 1/3, but now when I move this x to the negative 6 to the opposite position, it becomes x to the positive 6. So you don't have issues with negative coefficients or negative numbers, we only have issues with negative exponents. So your two examples for this one is negative 5x to the negative 2nd power. So that negative 5 and this x, they're not attached to each other. The only thing that negative exponent is going to is to x. So that negative 5 is going to stay right where he is, and we're going to move this x to the negative 2nd power to make it x to the positive 2nd power. So in the numerator we still have negative 5, but now in the denominator we have x to the 2nd power. On number 2, 4/8 will reduce to become 1/2. K squared over k to the 5th initially would become k to the negative 3rd, but it's because this really still belongs on the bottom. It should really be 1 over 2 times k to the 3rd. When you start getting more familiar with this, you're going to start realizing that that's happening because I've got 2 k's on top, 5 k's on bottom, and only 2 sets are canceling, so k to the 3rd really just needs to remain in the denominator. And so once I started getting more familiar with this, I would just find the difference but leave it where there were more of that variable. So I say there's 2 k's up top, 5 k's on bottom, there are going to be 3 k's left on bottom. And it just makes it a whole lot easier than having to rewrite negative here, switch it, fix it back. It just gets really complicated. Now, some additional examples with negative exponents. If I have an entire expression, so like 2x squared to the negative 3rd power, if I have it all to a parentheses, well, we remember that that goes to both things inside the parentheses. And there's that understood one. So I'm really looking at 2 to the negative 3 and x to the negative 6. I could distribute it and then move them both to the bottom to get 1 over 2 to the positive third, x to the positive 6. Or, since I'm noticing the entire parentheses is to a negative exponent, I can move the entire parentheses all together and switch it to be to the positive third exponent. So I really could look at this initially as 1 over 2x squared, now to the positive third power. And then I could continue to solve it from there, and I'd still come out with the same answer. If I have a fraction, so like if I have 1/2 all to the negative second power, what's really happening, I can distribute it to the top and the bottom, because when you have an exponent outside of a fraction, it is the power of a quotient rule here, and it has to go to the numerator and everything in the denominator. This is really 1 to the negative second power over 2 to the negative second power, and in order to fix it, I'd have to switch how they are. So when I have this, I know I'm really about to just flip it and then change the sign. So I'm really looking at 2 over 1 to the positive second power. So I could do it either way, but I just want you to know that when it's a quotient like that and it's to a negative exponent, you can flip the fraction and change it to a positive exponent, because that's essentially what's going to happen anyway. So this one gets a little complicated, but it's pretty much just putting it where it really belongs to try and change it to be a positive exponent.